everyone, welcome back to another video. So in today's episode, we're going to be doing something a little bit different than what is normal on this channel. What we're going to do is to examine Stainless Bros and Ticon's new Inc. 625 line. So before I really get into what the material is and what we're going to do with it and everything else, I'd like to issue a little bit of who I am and some disclosures. So if you guys are not familiar with me, my name is Alex and I run BP Autosports. For over a decade, I've been building exhaust manifolds, turbo systems, things along those lines, working with a variety of different materials and building record-setting parts. I have parts on the Boost and Performance Red Demon, the Accelerated Performance Blue Big Tire Supra, and a variety of other applications and cars. I've worked with a variety of different materials, exotic alloys, stainless steel, titanium, Inconel and nickel alloys, things along those lines. So without beating my chest too much, I have a good amount of history and a good pedigree of working with different materials and experimenting and learning what to do and what not to do with these different materials. Beyond my working history, what's my relationship with Ticon and Stainless Bros? Well, they are a sponsor of me and a sponsor of the channel and my company. I use their materials on just about every one of my projects, and I'm going to still try to be as unbiased as I possibly can in this review, but I just wanted to disclose that so that way there's no guessing or anything along those lines. In this episode, we are going to go over Ticon and Stainless Bros' new Inc. 625 line. We'll cover what it is, some do's and don'ts of working with nickel alloys, some different applications. We'll run some experiments and some tests, and hopefully by the end of this video, you will have a better understanding of what this material is, what it can be used for, its limitations and its strong suits, and hopefully it will allow you to make an educated decision if you would like to use this material on any of your projects. So let's begin by talking about what is Inc. 625. And what it is a high-grade nickel alloy comparable to Inconel 625. These high-grade nickel alloys are used in aerospace, motorsports, and industry, pretty much anywhere where high heat resilience and resistance to corrosion is extremely necessary. And these high-grade nickel alloys are perfect to be used in applications such as turbo manifolds and headers, downpipes, wastegate dump tubes, and pretty much anywhere where the part will see an extreme thermal load and extreme heat cycling. So why use Inc. 625 over stainless steel? And that's a very good question. Well, the first of a litany of different reasons why is the thinner wall thickness. And what this equates to are lighter parts. So compared to a normal stainless steel elbow that Stainless Bros would sell, that is 0.625 or 0.65 wall, 16 gauge, these Inc. 625 elbows, if I measure it out, they end up being 43 thousandths wall right here. On the other side, 45 thousandths, top side 44, bottom side 36. So the thinner the wall thickness that you can run on the material that you're using will equate to a lighter part in general. It's just a simple equation of how much material is actually being used to build the part. And just because the wall thickness is thinner on this material does not mean that it is weaker. Actually, due to this being a high nickel alloy, it's extremely resistant and resilient in these high heat applications. And you can get away with running a much thinner wall thickness than stainless steel while still retaining longevity and still providing a part that will stay together for the long haul. And beyond the beneficial material properties, these Inc. 625 elbows and tubing and all of the materials fall right in line with the rest of Stainless Bros and Tycon's materials, providing an absolutely beautiful surface finish both inside and outside of all of the pieces that saves you time from having to surface finish everything. You don't have to do that if the surface finish is already beautiful on the piece that you're using to begin the project. Another huge benefit of Inc. 625 over other high nickel alloys is its ease of acquisition. So prior to Tycon and Stainless Bros coming out with the Inc. 625 line, sourcing nickel alloys was very difficult. It was a bit of a cumbersome process. You had to define exactly how many bends, what bend radii you needed, exactly how many of them, as most of the shops that were selling this material are F1 shops. And while they tried to do their best with getting the materials and being easy to work with and everything, the fact of the matter is their priority lies with the F1 teams as opposed to small fabrication shops that may be working with the material. Now that is no longer the case with the Inc. 625 line. This material is just as easy to order as any of Tycon and Stainless Bros' other offerings are. You simply go on the website, pick out which materials that you need, different bend radii, everything else, and they have a very deep catalog of this stuff that is constantly expanding as well. And you check out simply like you would with any other material. No song and dance associated with it. It's really, really that easy. So let's get into some of the nitty-gritty of how to work with Inc. 625, as working with nickel alloys is a little bit different than working with stainless steel or any other material. And the first thing that I want to bring up with this is how to actually cut the material. So this is a 2-foot long section of 1 3/4 inch Inc. 625 tubing, and you can see the bandsaw in the background right here, and we really can't use that to cut this material. Now, there are some blades out there that are designed to cut Inc. 625, to cut nickel alloys. However, those bandsaw blades, I believe, are generally more or better suited for working with pipe and thicker wall materials. Not so much this thinner wall tubing that we will generally be working with in the automotive sector to build headers and things along those lines. So let's take a look, and I'll put my money where my mouth is, and let's see if my trusty old bandsaw can make a cut on this Inc. 625 tubing. All right, so if I take a section of tube and put it in the bandsaw, I'm guessing based off of my previous experience with nickel alloys that the bandsaw is not going to cut it. So I'm going to put my headphones on as I like to preserve my hearing, but let's give this a shot and see what happens. Well, it turns out that we can cut Inc. 625 with the bandsaw. That is a huge benefit over working with the other nickel alloys and other nickel tubing that I've used in the past, as cutting everything with an angle grinder, while it is doable, is not the easiest or the best way to do it. The next thing that I'd like to do is to make a cut on this Inc. 625 bend. And I want to see if cutting through the middle of the bend shows an oval side as opposed to a round side, as is traditional for most mandrel bends. It's just, or at least for traditional bends, it's just a function of the mandrel bending process. When you cut through them, one side will oval pretty badly, while the other side will remain round. So let's go ahead and make a cut on this. And actually first, let's take a look at this bend a little bit more. You can see no wrinkles, no abnormalities in the bend or anything like that. Just a beautiful, true bend that will provide beautiful aesthetics for the part that you're building. So with that being said, let's go ahead and make this cut, and let's see if one side ovals and one side still round. Now we can see with the cut bend that it has remained perfectly round on both sides of this, both the cut bend segments. So that is a beautiful thing for mating up to straight tubing. It makes it where there is no guesswork and there's no overlaps or anything like that. You guys can see there, just with me holding this together, the beautiful fit up and the beautiful joint alignment on all sides of it. So after cutting, deburring is a very important process. You guys first saw me flatten everything out on the big belt sander behind me, then put some bevels and do an exterior deburr on the smaller belt sander to your left. And finally, we'll go through and deburr the inside of it. I like to use just a deburring knife, and it works very well for these nickel alloys. You simply scrape around, take the burrs off of the inside of the piece, as we don't want burrs to make their way into the turbine wheel or anything like that. The better that you deburr something, the less chance that you have of causing issues that way that could be very easily avoided if you just would have taken a little bit of time to do your due diligence and to do your deburring. So now that we have two joints prepped and two joints ready to be welded, why don't we go over to the welding room and let's weld these two joints up and see how this material works and how it acts actually under heat and under an arc. Before we get started welding, let's take just a moment to talk about surface finishes. So these Ink 625 elbows and the straight tubing and all of the products, or all the Ink 625 products, all come with a beautiful brushed surface finish on them. And this saves a bunch of time from having to surface finish something yourself. Now, you could alter the surface finish on these pieces for sure. You could polish them, you could put a different style of brush finish on it, kind of whatever you want to do. But the fact that they come out of the bag with such a beautiful finish, both outside and inside, that saves a bunch of time. You can also, I'm sure you've also noticed that I'm wearing gloves, and I'll do that with any material, any part that I want to keep fingerprints off of. That's a big thing for me, is maintaining a beautiful surface finish without having fingerprints or other abnormalities or blemishes on the surface of the material. So the fact that Stainless Bros and Tycon have such beautiful surface finishes on their pieces straight out of the bag, straight out of the packaging, is a massive, massive benefit. So with that being said, let's go over to the welding room and let's run a couple of tests. Let's talk about welding nickel alloys now. And there are a few things that you want to keep in mind as you're working with this material. The first of which is back purging. So if you guys are not familiar with what back purging is, what you are doing in that process is filling the inside of the piece that you're welding with inert gas. In this case, it will be pure 100% argon. The reason for that is to shield the inside of the piece. Just like you shield the outside of it with a cup or a gas nozzle, the inside of the piece also needs to be shielded. Otherwise, it will pull in contaminants from the atmosphere and result in a weld that is not as strong as one that is back purged. And it will also result on a bunch of nastiness on the inside of the piece. And I'll show both of those here in a little bit. To aid in the back purging process, I'll be using TIG Aesthetics back purge plugs. What these are silicone plugs. The feed side has a diffuser screen, if you guys can see that there, whereas the vent side has just a tube. As to back purge, with the point being to displace atmospheric air from the inside of the piece, you need to have some sort of a weep or a vent hole, which, like I said, the plug with the tube in it serves that purpose. Beyond that, we also have two different filler rod options from Tycon and Stainless Bros. We have a larger and a smaller. So this larger size right here, if I mic it, or hit it with the caliper rather, comes in at 45 thousandths of an inch, or they have it marked on the tube at 1.2 millimeters. The smaller of the two filler rod sizes right here is 30 thousandths, or 0.88 millimeters, I believe is what that equates to in metric. So for this weld, since we're going to be beginning with butt joints, I'm going to use the smaller diameter filler rod. Being that this material is so thin, a thicker filler rod, you can run into issues with the filler rod quenching or cooling the puddle off, and therefore causing it to be erratic and to move around in kind of unpredictable and undesirable manners. I found that with thinner materials, thinner tubing, thinner filler rod generally works better to have a nice predictable weld, at least the way that I weld. So your mileage may vary on that. That's how I prefer to do it, and that's how we're going to do this right now. So with that being said, let's go ahead and gear up and let's run a couple of welds. For torch setup, I'm going to be using this Arc Zone Monster number 16 gas lens or gas nozzle. This is a pretty cool piece. It's what's called a champagne cup or champagne nozzle. As you can see, it's kind of shaped almost like a champagne glass, and it threads onto a medium gas lens. So you have dual diffusion essentially of the gas, and what that equates to is a nice plume of gas that comes off and shields the piece that you're working on, as opposed to a normal collet body style cup, which really just kind of jet streams the gas out and does not provide adequate shielding. So I'll run this cup in somewhere between 30 and 35 cubic feet per hour through the torch. On the back purge side, I'll run around 15 cubic feet per hour constant, continuous through the inside of the piece. And I'll also show you guys what happens when you do not back purge not only the weld, but the tacks as well. So hopefully you guys can hear me over the welder here. And what I'm going to do is to set up two joints, one of which will be back purged, the other of which will be not back purged. And we'll see the differences between the two. So I have my TIG Aesthetics purge plugs, and I've wrapped them in a layer of aluminum foil. I do this just to keep the purge plugs in better condition, as since they are just silicone, they can melt if you get too close to them with heat. So that aluminum foil provides a little bit of a buffer and keeps things happy. So I have my purge bottle open. I'm going to connect it with my quick disconnect line. And there's gas flowing through that now. If I fit this piece up, we can put 4 tacks onto it. And we'll see how those look. compared to the non-purge tacks. So keep my filler rod handy in case this tries to blow out on me. And here we go. So I'm running about 60 amps, or I have the welder set at 60 amps, I should say. I'm not using all of that, just as much as I need. There's a tack there, and I'll tack this in 4 places, equidistantly spaced around the joint, so that way it won't pull or do anything weird. The setup was nice enough there that I was able to tack it without adding filler rod. And that'll be my final purge tack right here. And there we go. So you can now see that I've removed all of the back purging apparatus. And now I'll put this side on and I will tack it without purging. And then we can take a look at what the differences are between the 2 sides. So same deal, I'll keep my filler rod handy in case I need it. Let's put this together. So I notice already that it's difficult to get the 2 sides of the material to butt up or to actually melt together effectively. That side I really needed to put some filler rod in to get the 2 sides bridged. There I was able to fusion pack that. And the final side over here, put a little bit of filler rod in there. So, let's go ahead and I'll run the non-purged weld first so we can see what's happening with that, and I'll kind of narrate what's going on, what I'm seeing, as you guys won't be able to see it, unfortunately, since the light is so bright. Then we'll let this cool down and run the purged weld, and we'll be able to see what it looks like side by side and get a good idea of the material that way. Alright, still on the same settings that I was before. Like I said, 60 amps on the machine. I have a 10-second post flow and around 35 cubic feet per hour flowing through the torch. Let's go ahead and run this non-purged weld, see what happens. So immediately with this material, I noticed that the puddle flows nicely and predictably and all of that. It isn't really giving me any fits. Nice smooth weld. I can definitely tell it's a little bit dirtier just due to not having gas flowing through the inside of it. But I'll keep working my way around this joint and we'll see what happens. Now that I've ran the non-purged weld, I'm going to go ahead and set up for the purged weld. So, just connected the hose, it is flowing gas through it, and I'll let it sit here for a couple of minutes just to expel whatever's on the inside of the tube. And then at that point in time, we'll be ready to start welding and to see how this material acts in kind of an appropriate manner, how you'd actually be welding it. So here we go, the initial arc strike, and let's see how this goes. So I noticed immediately that, like other nickel alloys that I've worked with in the past, the puddle is kind of dirty and difficult to see. Many times when you're welding nickel alloys, you're kind of doing it based off of feel rather than huge visual cues. But it seems to track along nicely. The puddle's predictable, and so far so good with this weld. I'll run it the whole way around, and then we can compare and contrast on the inside of the piece and see the real money and business side of why purging makes such a difference. All right, with our 2 test welds ran, we can take a look at both the exterior aesthetics, coloration, everything else, as well as what both welds look like on the inside. And the difference is quite stark. So with my light here, we look, I guess let's look at the outside first. And from this perspective, this weld on the left is the one that was purged. This weld on the right is the one that was not purged. And we can see already there's a bit of an aesthetic difference, at least just on the outside of the piece. This weld on the left that was purged, you can see through it, although the puddle is a little bit muddy, or the weld is, and that's just a function of this material, you can see less kind of contamination and coloration and stuff like that on the outside, which says to me that the purge was preventing the weld from picking up a bunch of crap on the inside. Speaking of the inside, if we look at the inside of the tube, I'll zoom you guys in, and that is the non-purge side right there, which you can see all that gray, scaly nastiness on the inside, as opposed to the other side that was purged. You can see a nice smooth weld whole way through, full penetration, no nastiness, no stalactites, stalagmites, anything like that. And that should be pretty illustrative as to why purging is as necessary as it is. Now, beyond the actual welds themselves, a tack weld is just a small weld, right? So tacking, it's necessary, at least in my opinion, to purge as well. So I cut a couple of other test pieces, and this one on the left is not purged, this one on the right is. We can see even just from the tacks, if we look at kind of the exterior of it, the non-purged one on the left there, you can see some color around the tack that is no good. On the right, no color, which is good. And then if we look at the inside of these pieces, this non-purged one, if I zoom you guys in, then you can see the nasty oxidation on the inside. If you put a lot of heat into a purge, then it's going to get through the tube and provide all that nastiness that we saw on the non-purged weld on the inside. And even if it's just a tack, you still will be running over that nasty oxidation on the inside and pulling that stuff into your nice clean purged weld if you go over top of it, following kind of that series or that sequence of operations, order of operations rather. The purged tacks, again, if we look on the inside here, you can see nice little silver tack there, same there, same there, and then fourth one, same there. And If you purge your tacks, then you provide a nice purged little spot weld essentially to run over easily with the actual weld that you're doing on the piece without pulling any crap into it, making nasty spots that inevitably will be in the most visible portions of the piece that you're working on, and it's just a bad deal. So my advice to you is on any reactive metal, just purge your tacks. It takes a few extra moments to set up, and it takes a little bit of getting used to do so, but the benefits are massive for doing it, and I really think that the effort is worth it. So with that being said, we're going to move on to our next demo, and that is welding Inc 625 to stainless. And I have this test joint set up right here. Granted, this isn't exactly the style of joint, or at least not the angles that you'd be running on a wastegate provision or something like that. And typically, you would be welding Inc 625 to a stainless flange or something along those lines. And although this joint is not the same as that, it still serves as the proof of concept to show that you can weld this nickel alloy to stainless. So on the bottom, you can see I labeled it SS for stainless. It's just a piece of 304 stainless tube. And I just drilled a simple weep hole into the stainless tube, and I'll purge this and everything will be cool. So I have 4 tacks on it currently. Got the joint set up and coped and everything as nicely as I could. So let's go ahead and run this test weld, and I'm going to use the Stainless Bros Inc 625 filler. I'm going to start with the 30,000th or 0.88 millimeter filler rod and see how that works, and potentially swap over to the 1.2 millimeter or the 45,000th rod and see how that works as well. The Inc 625 to stainless weld came out pretty nicely. I'm happy with it, and I'm happy with how the filler rod played with both materials as well. So on this side of the piece, starting from the initial point right there next to my thumb, this first portion of the weld was done with the 30,000th filler rod, and you can see it's a little bit narrower. And once we get over to this point, pretty much from right next to where my thumb was, looping all the way back around to the initial start-stop point, that was welded with the 45,000th rod. You can see the weld is a little bit wider, the ripple is a little bit more pronounced through it, which is to be expected. Since you are running, or since you're using a larger filler rod, you have to apply more heat to melt the rod, which then will therefore apply more filler, and that's how you end up with the broader weld with a more defined ripple pattern. But the filler rod selections that Tycon and Stainless Bros offer seem to work quite well welding this Inc 625 tubing to anything stainless steel. And if you already have nickel filler rod on hand or searching elsewhere to acquire it, ERNICR-3 is another good option for welding any nickel-based alloy, specifically Inc 625 or Inconel 625 tubing to stainless steel. Now that we've ran a few welding tests, let's take a moment to talk about some considerations and I guess limitations with Inc 625 and building parts with it. And mainly, this really boils down to leverage and support. What I mean by that is how you tie in things like wastegates and how you mount things like turbos when using thinner wall tubing like this. As great as Inc 625 is at resisting high heat, it does have a limit as to its structure. Being a thinner wall tube, you don't want to hang a 40 or 50 pound turbo off of it, nor do you want to have a wastegate with like 1 foot of leverage hanging off of the side of off of the side of a merge collector. So what I suggest doing in terms of turbos, I suggest mounting them using something like a Maven mount, an oil drain mount, or some sort of a mounting strategy to support the weight of the turbo. That way, the header, the turbo header, is not being used to support that much weight, and you won't run into a premature failure just due to that much weight being hung off of this thin wall of tubing. Similarly, with wastegates that can have a lot of leverage off of the merge collector or wherever you have them mounted, that can vibrate and shake around and everything, I suggest reinforcing the wastegate provisioning, using something like gussets or reinforcement sheet on the merge collector, or a combination of things like that. And that will just help provide additional longevity to the part. And I suggest even doing that with stainless tubing as well, as kind of the same principles of leverage and weight do apply. And that about brings us to the end of the Inc. 625 video. And after the bit of playing around that I've done with it here today, and talking to the Tycon and Stainless Bros crew, I feel confident at this point in time saying that Inc. 625 is a great material option to make parts that are both as light as they can be and as resilient as they can be in these extreme high heat environments that you'll see in a header, a downpipe, wastegate dump tubes, or things along those lines. Now bear in mind that Inc. 625 does take some special precautions and special measures to work with. Even though we were able to make the first cut on the bandsaw, I attempted to make additional cuts on the bandsaw, and I could tell the blade was starting to get unhappy. So I stay with what I have always said with any nickel alloys: probably cut those with an abrasive wheel as opposed to a bandsaw. I probably prematurely started to wear out my bandsaw blade, but that's okay. It's all for the sake of experimenting, learning a new material, and I still stay with my recommendation of using abrasives to cut this material. In addition to that, we've seen kind of the benefits of back purging over not back purging, and if you're going to the lengths to make a piece or to make a part out of Inc. 625, it behooves you to back purge it. It doesn't take that much more time, doesn't take that much more effort, and the benefits of doing so are immense. Now this material is currently readily available through Tycon and Stainless Bros. They have, at the time of filming this, 1.5" and 1 3/4 tubing options, as well as bends and things along those lines, and they have additional sizes coming. I don't want to state what all those are right this moment, as it is subject to change, and the stuff is not out right this moment. But they will have more sizes coming to better accommodate larger header builds, larger wastegate dump tubes, downpipes, and things along those lines. So keep your eyes peeled on the Tycon and Stainless Bros websites to see when the full Inc. 625 line has been released. Now, if you don't want to buy a bunch of tubing and bends and things like that, and you really just kind of want to try your hand at this new material, they offer these handy sample starter kits. They come with 5 pre-cut segments, some pre-cut lengths of filler rod in different diameters, and this is a great way to kind of test the waters with this material and get used to working with it rather than buying it for an entire project and having to learn on the fly. With this material being a bit more expensive, it kind of behooves you to practice first before you just start running down the road. And last but not least, I'd like to issue a huge thank you to the Tycon and Stainless Bros crew for not only bringing this product to life, but providing me with the opportunity to play with it, to try my hand at it, to give my feedback on it, and to experiment with it, as I have some projects coming up that I would really like to use this on, and I look forward to doing just that. And a huge thank you to them as well for supporting everything that I do here, for being a huge part and playing an integral role in the setups on all of the different cars around here. So Keen, Justin, thank you guys very much, and the rest of the whole crew. and I look forward to working with you for many more years into the future. And with that, I think that's a good place to leave off for this video. So thank you guys, as always, for coming along on all of these different journeys and all of these different adventures with me. This was a cool one, getting to experiment and learn a new material. And it's, like I said, one that I plan on using on many projects in the future to provide and to build the best parts that I possibly can. So if you guys have any additional questions about Inc. 625 or any of Ticon and Stainless Bro's other materials, as they have 4 different material offerings at this point in time. They have the stainless line, they have the titanium line, they have the aluminum line, and now they have the Inc. 625 line. So if you guys have any questions about any of those different material offerings, please reach out to the Ticon and Stainless Bros crew, and they can get you squared away with whatever you need for your project. If you have any more questions, or if you have any questions for me, or want any additional information about working with Inc. 625 or nickel alloys, feel free to leave comments down below, and I will do my best to get back to you about them. But with all of that being said, I think that'll be about the end of this one. So as always, be sure to subscribe, leave a like, leave a comment, and check out the website for manifolds, for merch, and for all things good that way. With that being said, that'll be the end of this one, and I will see you guys in the next episode.